So now that we've practiced converting polar equations to rectangular equations, let's go the other way around. Let's practice taking an equation that is rectangular, meaning it is expressed in terms of just x and y, and converting it into a polar equation that uses either r, theta, or both. So I went ahead and I've written down 3 of the primary key formulas that we're going to be using. And just like before, there's not necessarily a step 1, step 2 kind of linear fashion to this. Sometimes it's just looking at the equation and just asking ourselves what formulas would make the most sense to apply here, given what we're given. All right. So starting with the first one, we got y equals -2. So looking at y is equal to -2, go back and look at the equations and formulas that you just wrote down. What would make the most sense? Well, looking at them, we know that y is equal to r sine theta. So let's use that. If y is equal to r sine theta, we can say that replace the y with just r sine theta and set that equal to -2. Now, this right away already is a polar equation, but we typically want to write all of our polar equations as functions of theta. So in other words, isolate r. And that here is pretty simple. We can just say r is equal to -2 over sine theta. And might as well clean that up a little bit. R is equal to -2 cosecant theta. So if you ever can use your reciprocal identities, you should. So there's our first one. Looking at our next one. 4x plus 7y minus 2 is equal to 0. Well, here we've got a couple substitutions. We know by now that x is equal to r cosine theta, so I'm going to write that in for r cosine theta. And we know that y is equal to r sine theta. And let's go ahead and just move that constant of 2 over to the other side. Now, looking at this here, we've got to pretty much just do some inverse operations and some reorganizing in order to isolate r. So I'm going to start by factoring out the r. And we're left with 4 cosine theta plus 7 sine theta. And from here, there's really not much more I can do other than just divide both sides by 4 cosine theta plus 7 sine theta. So I'm just going to write this as 2 over 4 cosine theta plus 7 sine theta. And there's our answer there. There's not really any other identity I can use to clean that up. Now, our final one, before we try a few practice problems on our own. We've got x squared plus y squared minus 8y equals 0. So again, look back at our identities here and ask ourselves, is there anything I can use to substitute? And hopefully this jumps out to you right away. X squared plus y squared is equal to r squared. And we're going to use that. So going back here, we know all of this is just equal to r squared. And y is equal to r sine theta. So we're just going to substitute. That's all this is constantly. And from here, I'm going to go ahead and find a way to isolate r. So the first thing I can do is just move 8r sine theta to the other side. And usually we have a problem with what I'm about to do if we were working simply algebraically with rectangular equations. But since we're writing r as a function of theta, that's not an issue here. So we can just write this as r is equal to 8 sine theta, and that is totally fine. Now, I encourage you to, again, try to pause this video right now and try some of these problems on your own. So let's check in together now and check our answers on a few of these. So we're just going to go through and we're going to substitute what we know, what we can rewrite in terms of r and theta. So we got 2 times r cosine theta plus 5 r sine theta. And we're just going to move all those constants over to the other side. So we've got -4 here. Since I'm trying to isolate r, I'm going to factor it out. And then from here, again, there's not really much else I can do except just to write this as there's that. Okay, let's try this next one here. Here, there's really not much we can do here other than to remember that x is equal to r cosine theta and y is equal to r sine theta. Well, if that's the case, we can write this as r cosine theta, this entire quantity squared, is equal to r sine theta, and again, all of that cubed. Well, let's clean that up a little bit. R squared cosine squared theta, r cubed sine cubed theta. And just like we did before, we're going to just divide out r squared from both sides. And we're left with then cosine squared theta. And I'm just going to divide this right side by sine cubed theta while I'm all at this. And that's equal to r. And if I wanted to clean this up a little bit, I can just go ahead and write this as, and while I'm cleaning it up, might as well rewrite this because that was not a good looking sign. So r is equal to cosine squared theta over sine squared theta times 1 over sine theta. And hopefully you can see how we might be able to use some identities to rewrite this as r is equal to cotangent squared theta cosecant theta. And there's that. Now, final one. And again, if you haven't already tried this, I would encourage you to really sit there and think about this one because this is a good problem. Now, there's more than one way to do this. I'm going to go with the one that I felt was actually the cleanest one here. And again, if this is not what you did, that's totally fine. But here's how I thought about this. I know that y squared, well, let's take a step back. If I remember my Pythagorean identity, I can say that x squared plus y squared is equal to r squared. So that means y squared is equal to r squared minus x squared. So using that substitution, I'm going to rewrite this y squared as r squared minus x squared. And I'm just going to continue to just bring down everything else from the original equation. And once I have that, I'm going to isolate r squared. So right away, I've already gotten something in r, but I still want to see if I can rewrite that x squared plus 8x plus 16 in terms of either r or an angle theta. And I see that that is a factorable polynomial. So I can say this as r squared is equal to x plus 4 squared. So that means r squared is equal to, and replace that x now with r cosine theta plus 4, all of that squared. And let's now take the square root of both sides, because again, our goal is to try to see if we can isolate r. So if I take the square root of both sides, I got r squared is equal to plus or minus r, well, let's put all this in parentheses, cosine theta plus 4, which gives us two different possible polar equations. We got r is equal to positive r cosine theta plus 4, and then r is equal to negative r cosine theta minus 4, which involves us cleaning this up as r minus r cosine theta is equal to 4. So then r, once I factor it out, can then be written as 4 over 1 minus cosine theta. And this over here would be r plus r cosine theta. And the same steps pretty much that I just did on the left side. So again, this may not have been the way that you did it, but that totally works. Well, that recognized it. Now it's kind of awkward not to have that in a nice looking box. So let's see if it'll do it again. There we go. Okay? So that was a good problem. It was a challenging one, and it really tested how well you know not only these formulas, but also how well your algebra, like how good your algebra skills are at this point. So I encourage you to now go ahead and try those practice problems. Really practice converting both rectangular equations to polar and the other way around.